Rutherford's big contribution to atomic physics was the proposal that the majority of the mass and all the positive charge in an atom is concentrated in a small region of space which is known as the nucleus. So Rutherford based this theory on observations that he got from an experiment he asked Geiger and Marsden to conduct between 1908 and 1913. So Geiger and Marsden fired alpha particles at thin gold foil, and they looked at what happened to the alpha particles. So they measured how many alpha particles were being observed all around the apparatus. Now, what didn't surprise Rutherford and Geiger and Marsden about this observation was that most of the alpha particles were not deflected. So Rutherford saw this as evidence that most of the atom is empty space, as empty space does not deflect particles. The surprising thing was that some of the alpha particles were deflected, and some were deflected an awful lot. Some managed to go back along the same path on which they entered. So Rutherford interpreted this to mean that the positive charge was very concentrated inside the atom. So this suggested that all the positive charge was in that nucleus. And that's because if you have concentrated charge, you have a much stronger electric field, which is going to deflect the particles. He also noted that not many of the alpha particles were deflected, and so from this he could use the number that were deflected to estimate the size of the nucleus. The size of the nucleus was much, much, much smaller than the size of the atom. So Rutherford's model of the atom basically consists of a nucleus which contains protons, and he suspected that there may also be something similar to neutrons in the nucleus as well, because he realized that all the mass, well, the majority of the mass of the atom was in that nucleus. So around this nucleus, he said that electrons were orbiting in circular orbitals, and he said the charge on the electrons balanced the charge in the nucleus. So atoms were overall neutral. Now there were a couple of problems or shortcomings with Rutherford's model of the atom. One of the primary shortcomings is these electrons in orbitals. We know that if something's undergoing circular motion, then it's accelerating. And Maxwell's equations had just shown that accelerating charges moving in electric fields are going to emit radiation. So this tells us that these electrons circling around the nucleus should be emitting radiation, and if they're emitting radiation, they're losing energy, and so basically they're going to slowly spiral into the nucleus, or as it turns out, not that slowly. In fact, Rutherford, atoms were only stable for around about 10 to the minus 8 seconds, and then they decayed as these electrons moved into the nucleus. So he couldn't explain why we had stable nuclei. The other big shortcoming of the model is that it didn't account for the different orbitals at all. So any of our observations which result from the structure of the different orbitals, so for example the different spectral lines in which we observe from different elements, can't be explained through the Rutherford model of the atom. So to conclude, Rutherford did make a big step forwards. We now know that the majority of the mass of the atom is concentrated in the nucleus. So the nucleus contains positive protons and neutral neutrons, and all the positive charge within the atom is in that nucleus. But obviously we need a bit more of a complex model to explain all the spectral lines and other things that we observe.